Dear students, the previous class we are discussing about corrosion, definition of corrosion, and then types of corrosion, theories of corrosion, types, theories, and factors affecting the corrosion, and prevention. Now these are the four important subheadings coming under that corrosion topic. Now in the previous class we are discussing about definition of corrosion. I think all of you know that the corrosion can be defined as the destruction or deterioration of metals or alloys by chemical or electrochemical attack in the environment, that is called metallic corrosion. Now the types, general types is in dry and wet corrosion. Dry corrosion is explained by differential aeration theory of corrosion. The wet corrosion is explained by electrochemical theory of corrosion. Now we have studied the electrochemical theory of corrosion. The concept of differential aeration theory is where oxygen concentration is less, that portion always act as anode, more oxygenated surface act as cathode. That is the concept of differential aeration theory. Now today we are going to study about the types of corrosions. Now general type, dry and wet, they are further classified into many types. Now already the previous class also we have studied the theory, electrochemical theory of corrosion, anodic reaction and cathodic reaction. The cathodic reaction depends on the medium, either may be acidic or may be basic or may be neutral, or in absence of oxygen or presence of oxygen. By considering all possible conditions, the electrochemical theory, it explains satisfactorily how corrosion takes place. That we have studied and understand that. Now let us continue that. Now today I am going to take up the types of corrosions. The types of corrosions. Now types of corrosions, there are so many types are there, out of which there are three important types of corrosion. There are three important types. One is galvanic corrosion, galvanic or differential metal corrosion, differential metal corrosion, and second one is pitting corrosion, pitting corrosion, and third is waterline corrosion, water line corrosion, and stress corrosion, boundary line corrosion. Likewise, there are so many types of corrosions, they can be classified into different types, out of which there are three important types today I am going to discuss. That is, the first one is galvanic or differential metal corrosion, second is pitting corrosion, third one is waterline corrosion. Now take up that first one, that is a galvanic or differential metal corrosion. The differential metal corrosion, that name itself says, they are considered there are two different metals each other. One of the metal undergo corrosion. Now two different metals, you consider any two different metals. There are corrosion, galvanic or differential metal corrosion occurs only when there are two dissimilar metals are connected each other by means of electrical wire and immersed or exposed to a electrical solution. Now electric solution, that is an galvanic corrosion takes place. Now I will consider there are two different metals. For example, I will take this one is an iron, another is copper. Iron metal, because corrosion takes place either on same metal or on different metals. Now I will consider this a copper and one is an iron. Now these two are connected by means of electrical wire and immersed in a electrolyte. Suppose you are exposed to electrolyte, one of the metal undergo corrosion. Which metal undergo corrosion? Either iron is undergo corrosion or copper is undergo corrosion. Now that can easily understand that by knowing the electrochemical series of metals or galvanic series. On the basis of electrode potential of metal, they are classified. The series of metals they are mentioned. For example, iron, it has minus 0.44 electrode potential. Iron metal, it has negative potential minus 0.44. Likewise, this is a copper, it has positive 0.34 electrode potential. Likewise, you suppose take that zinc that carries negative 0.476 electrode potential, that is in volts, that much of electrode potential. Now, which metal it has high negative potential? High negative potential, that metal undergo corrosion, that metal act as anode. High negative potential in the galvanic series, which metal is higher up, this always act as anode, that is more active, they undergo corrosion. Now we consider iron and copper. Now iron and copper I taken here. Iron it has minus negative point, this is electrode potential. Copper is a positive. Now if these two are connected each other, now electrons are transferring from iron to copper. Now iron metal act as anode and copper act as cathode. Because iron it has high negative potential, this is more reactive and more active, they undergo oxidation, that will act as anode. Now anode and copper act as cathode. Suppose you consider these two metal, iron undergo oxidation, it lose their electrons and electrons are transferred from anode to cathode. Cathode is free from corrosion, but anode always corrosion takes place at anodic region. Now this is an example. This type of corrosion that is called galvanic or differential metal corrosion. Now out of these three, they may ask in the examination any two for 4 marks each. Galvanic or differential metal corrosion or pitting corrosion, or maybe these two, waterline and corrosion. Now you take instead of copper and iron, suppose I will take this copper and zinc. Copper and zinc. These two metal connected each other. Which metal undergo corrosion? Now zinc is more reactive because it has a high negative potential, copper is positive. Therefore, zinc act as anode and copper act as cathode. Now electrons are transferring from zinc to copper. Likewise, suppose you take iron and zinc. Likewise, you can take any metal, iron and zinc, these two are connected each other. Zinc is more reactive or iron is more reactive now. High negative potential, this is the high negative potential than iron. Now compared to these two, iron and zinc, iron is less negative potential, zinc it has high negative potential, 0.76. Now this zinc act as anode and iron act as cathode. Here also electrons are transferring from anode to cathode. Always electrons are transferred from anode to cathode, current is flow from cathode to anode. Corrosion current is created here. This type of corrosion is called differential metal corrosion or galvanic corrosion. When electrons transfer from one electrode to other or one place to other place or jumping from anode to cathode, it develops some potential difference. That's why the galvanic cell formation. Due to formation of galvanic cell, one of the metal undergo corrosion, that's called it as differential metal corrosion or galvanic corrosion. That's about galvanic corrosion. Next we go for pitting corrosion. Pit means hole. Pitting corrosion takes place only when a pit or hole is created on the surface of the metal. For example, windows rod. Now just I taken this windows rod, that is an iron metal, iron. Now some dust particle deposited over here. Now this type of corrosion, a pit or hole is created on the surface of the metal. That type of corrosion is called pitting corrosion. That is explained by the differential on the basis of differential aeration theory of corrosion. Now on the basis of differential aeration theory concept, you can easily to explain pitting corrosion and as well as waterline corrosion. Now as per in the previous class we were discussing about the differential aeration theory and electrochemical theory. What is the concept of differential aeration theory? Less oxygenated surface always act as anode, more oxygenated surface always act as cathode. That is the concept. Now you can apply that. Now pitting corrosion can easily explained by using differential aeration theory. As per differential aeration theory, dust particle deposited over the surface of the metal. Below this dust particle, oxygen concentration is less compared to this. This is more exposed to the atmospheric oxygen. This is more oxygenated area. Therefore, this act as cathode and less concentrated oxygen concentration. Therefore, this portion act as anode. Now, you can see that corrosion takes place either on same metal or on different metals. Suppose in the same metal, one portion undergo oxidation, other portion undergo reduction in the environment. Now oxidation, reduction, simultaneous reaction, but corrosion takes place due to only oxidation. When undergo oxidation, reduction automatically takes place. Now anodic area, there is a less oxygenated surface act as anode and more oxygenated surface act as cathode. In this case, anodic area is, see that anodic area is less compared to cathodic area. Therefore, all electrons, the oxidation takes place at anode, reduction takes place at cathode. Now, oxidation takes place when electrons are liberated. All electrons are accepted by the cathodic region. Therefore, it is more concentrated on anodic area. Therefore, it forms a pit or hole. A pinholes are created on the surface of metal surface. That type of corrosion is called pitting corrosion. Now, we can easy to observe in the windows rod after painted. Now, is one of the method to control the rate of corrosion. Painting is done on the surface of any object. That is one of the best method to control the rate of corrosion. Some duration, it may be 6 months or 1 year, and then you can see that a small drops, the block points are created on the surface. That is called pitting corrosion. That is due to the oxygen concentration variation on the surface of metals. Now, this type of corrosion is called pitting corrosion. Next, come to that waterline corrosion. Now, waterline corrosion takes place only when the water is stored for a long time in a iron vessels. Suppose I will take this iron vessel, okay. Now, this is an iron vessel. Now, I will store a long time for water. Now, water is filled for a long time in a container. This is an iron container or iron vessel. Now, if you store water for a long time, now corrosion takes place. Where it takes place? Corrosion either the bottom of this container or the top or in the middle. Actually, the corrosion takes place at this portion. Now, in the both the portions. Suppose it's an iron vessel. Here starts corrosion. Here starts corrosion, because this also explained. Waterline corrosion also explained on the basis of differential aeration theory of corrosion. Now, as per the differential aeration theory of corrosion, less oxygenated surface always act as anode, more oxygenated surface act as cathode. Now, this is the more oxygenated surface, below this waterline, that portion act as anode. Now, you see that. Now, this is the waterline, that is why they call it as waterline. Now, waterline, above the water surface, oxygen concentration is more, because its atmospheric oxygen concentration higher than that of dissolved oxygen present in the water. Now, inside the water, dissolved oxygen concentration is less compared to atmospheric oxygen concentration. Therefore, the difference you can easy to observe only at the surface of the water. That is a water line. Above the water line, more oxygenated. Below the water line, less oxygenated. Therefore, the less oxygenated surface act as anode, more oxygenated surface act as cathode. The both the sides, they starts corrosion. Then you see that another example, excuse me. Now, consider that the glass vessel now, instead of iron, I will take on this glass, okay. Now, this glass vessel, I put a water, so now off of that, the full water is filled with a glass vessel. I put a piece of iron, that is a piece of iron, I kept a piece of iron, I keep it that piece of iron here, where it starts corrosion, either in the top of the metal or in the bottom or in the center. Now, actually is that the water line only can easy to observe the difference of oxygen concentration, atmospheric oxygen and dissolved oxygen concentration varies only at this particular place. That is called waterline corrosion. Above that waterline, oxygen concentration is more, therefore, that portion always act as cathode and less oxygenated portion always act as anode. Below the waterline, that portion act as anode. Now, here starts corrosion. When contact with water, it dissolves. That is, solubility is one of the factor. I will take up after classification, then I go for the factor. This is also one of the factor. Now, dissolve, the nature of corrosion product is the one of the factor which dissolves in water, the rate of corrosion is high. It is insoluble and non-porous, then rate of corrosion decreases. Now, in this case, we are taken that iron vessel. both the sides starts corrosion because it's an iron vessel. Above that level water line there is a more oxygenated cathode, less oxygenated surface anode. Here starts corrosion. But in this case we are put the metal metal piece inside the water. Now in the middle there starts corrosion. There starts corrosion here. Above that portion act as anode, below that water line act as anode. This is a cathode. Now oxidation reduction takes place, electron transfer from anode to cathode. Then you see one more example. Now this is a glass vessel, just I fill the water, okay. Now fill the water, I immersed completely the metal piece, the iron metal or any metal piece I completely kept inside the water. Now immersed inside the water that metal, this is an iron metal, there is also iron metal. Here I immersed half of the portion, but here I completely immersed inside the water. Now as per the differential aeration theory of corrosion, they can easy to explain how takes place fitting corrosion and waterline corrosion. Now you see that in this case the metal is completely immersed in the water, is unaffected, that is an unaffected, is not undergo any corrosion, is free from corrosion. It is free from corrosion because inside the water oxygen concentration is uniform. Dissolved oxygen concentration inside the water is uniform. There is no difference in oxygen concentration. Therefore this metal does not undergo corrosion. That we can observe when immersed inside, completely immersed inside the water, the metal is not affected. When half a portion they are immersed, they starts corrosion. Now when you are completely immersed in a long time, then you can expose to the atmospheric oxygen. Then what happens? Either they undergo, some portion undergo corrosion or complete surface undergo corrosion. When you are immersed inside, is not affected. After some duration, after some time, it may be 24 hours or 6 hours, whatever, then you can take out and expose to the atmospheric oxygen, the whole surface undergo corrosion. That we can understand that this type of corrosion we call it as waterline corrosion. This type of corrosion we call it as pitting corrosion. If you consider two different metals, one of the metal will undergo corrosion, that we call it as differential metal corrosion. That is about types of corrosions. In general they are classified into dry and wet. Further classification, galvanic or differential metal corrosion, pitting corrosion, waterline corrosion. Some other also there, stress corrosion, boundary line corrosion. But now these are the three important, just you have to understand these three now. Now that's about types of corrosions. Next I'll go for factors affecting the rate of corrosion. Now what are the variable factors to influence the rate of corrosion, to undergo corrosion? Which are the factors? There are 5 important factors are there. Now I'll take up that 5 important factors. Factors affecting the rate of corrosion. Now we can understand that definition of corrosion, theories of corrosion, the concept of differential aeration theory, and further classification types of corrosion. There are 3 important: differential metal corrosion or galvanic corrosion, waterline corrosion, pitting corrosion. Then you come to that factors affecting the rate of corrosion. Factor affecting the rate of corrosion. Now there are 5 important factors. Are 1, that is a nature of corrosion product. Nature of corrosion product. Nature of corrosion product. Okay. Second one is anodic and cathodic area. Anodic and cathodic area. Anodic and cathodic area. That is also one of the important factors to. There are 5 important factors. And third one is conductivity, or this is an conductivity, then pH, then temperature. Now these are all the 5 important variable factors will influence the rate of corrosion. Now 5 important factors are nature of corrosion product, anodic and cathodic area, conductivity, pH, temperature. Now let us take one by one. First one is nature of corrosion product. What is the primary product of corrosion? The primary product of corrosion is rust or UST, rust. Okay. Now rust is the primary product. The product that is done in the form of ore, because all the metals are tried to get their original state. What is the original state or natural form of metals? Either oxide form or carbonate, bicarbonate or sulfide. These are the natural forms of metals are available in the earth crust. Most of the metals are available in the earth crust in the form of oxide. Now metals undergo oxidation, it forms a oxide layer that is called rust, that is also ore form. Now most of the metals undergo corrosion, it forms a rust that is in the form of oxide layer. Now we can easy to identify the rate of corrosion, whether it is corrosion takes place high or less corrosion. Now on the basis of thickness of the product. A thin layer is coated on the surface of the metal, that indicates the rate of corrosion is easy to determine the rate of corrosion is less. A thick layer is formed on the surface of metal, that indicates the rate of corrosion is high. The nature of corrosion product. Now nature of corrosion product is oxide or is rust. The primary product of corrosion is rust. Now rust undergoes soluble and porous. Soluble and porous. The nature of corrosion, soluble and porous, soluble and porous, then rate of corrosion increases. The corrosion product is soluble in water or any liquid media, soluble in water and it containing porous, then automatically rate of corrosion increases. Now for example in the waterline corrosion, now in the center there starts corrosion, this product is formed, rust. Now rust when contact with the water, then it dissolves. When it dissolves, the surface become free, then they undergo further corrosion. That indicates the rate of corrosion increases. Now suppose that some metals, for example, these are the metals either zinc or iron, these metals undergo oxidation and it highly soluble, that products are soluble and porous, then rate of corrosion increases. Then what about insoluble? Suppose insoluble and non-porous, then automatically rate of corrosion decreases. The primary product of metal, it is an insoluble in water and non-porous, then automatically rate of corrosion decreases. Soluble and porous, rate of corrosion increases. These are the examples of metals. Non-porous and insoluble product, for example titanium, okay, chromium or molybdenum, etc. These metals undergo corrosion, it forms a layer, that layer is insoluble in water and non-porous, then automatically rate of corrosion decreases. This is the example of nature of corrosion product. Then I come to that anodic and cathodic area. Now I come to that anodic and cathodic area. Now what you have studied in the pitting corrosion, that is the best example to explain anodic and cathodic area. Now in the pitting corrosion, what you have seen that, now this is the iron metal, some dust particle deposited over the surface. Now this portion act as anode and more oxygenated surface act as cathode. Now this portion act as anode, more oxygenated portion act as cathode. Now I will write the same structure. Now suppose here the same iron metal, here dust particle deposited maximum. Now you see that is the anodic and cathodic area effect. Now anodic and cathodic area, which one it gives more corrosion? Now this is anodic area and this portion is cathodic area. In this case, anodic area is less compared to cathodic area, therefore rate of corrosion increases. Anodic area is less, cathodic area is more, rate of corrosion increases, and vice versa. That is, an anodic area is more, cathodic area is less, rate of corrosion decreases. How it decreases? See that in the first case, anodic area is very less, this portion undergo oxidation, it liberate electrons, all liberated electrons are accepted by cathodic zone, because cathodic area is more, it receives the electrons and undergo faster reaction. It's a more concentrated on anodic area, therefore it forms a pit or hole is created in that case. Now rate of corrosion is very high. Similarly, anodic area is more, cathodic area is very less. Now anodic area is more, this portion undergo oxidation, these electrons are liberated, more number of electrons are liberated, but receiving end cathodic area is very less. Therefore, the receiving end is less, it not receive all the electrons are accepted by the cathodic zone, then automatically rate of corrosion is decreases. That is called anodic and cathodic area effect. Anodic area is less, cathodic area is more, rate of corrosion high. Anodic area is more, cathodic area is less, rate of corrosion decreases. That is the explanation. Okay. Then I come to that conductivity. Now I will take up this conductivity. Now conductivity, what is meant by conductivity? Conductivity is the reciprocal of, conductance means is a reciprocal of resistance. Okay. Now conductivity is more, rate of corrosion, conductivity is more, rate of corrosion also more. Conductivity is less, rate of corrosion less. For example, the dry surface. Now when dry surfaces, the rate of corrosion is less compared to wet atmosphere. Dry atmosphere and wet atmosphere, if you consider, suppose it is a iron metal, it is a dry atmosphere, suppose you take another metal, if you wet, now in the wet atmosphere rate of corrosion faster compared to dry, because conductivity is more at wet condition. That is, a conductivity is more, rate of corrosion also more. Conductivity is less, rate of corrosion also less. Likewise, you are going to explain that conductivity and also the anodic and cathodic area. Then I come to the pH. The pH can be defined as, how can you define that pH? pH can be defined as negative log of base 10 hydrogen ion concentration. pH can be defined as negative log of 10 H plus ion concentration. That is the definition of pH. Now pH, on the base of pH, the solutions can be classified into acids, neutral solution and base. Now acids, the pH value between 0 to 7 or 6.9 and like that. 7 exactly is a neutral, 7 to 40 is a base. Likewise, you are classified on the base of pH. Now pH increases, basicity increases. pH decreases, acidity increases. Now pH, it comes down less than 3, acidic condition is more. In acidic condition, the pH is very less, the rate of corrosion is very high. The severe corrosion takes place in pH is less than 3. Now the pH decreases, the rate of corrosion increases. pH decreases, rate of corrosion increases. Then pH increases, rate of corrosion decreases. pH increase, then the rate of corrosion decreases in the acidic medium and basic condition. In the basic condition, rate of corrosion is less compared to acidic nature. Now acidic environment, always the corrosion rate is very high. Now this is a pH value, that is a pH. Now pH is less, rate of corrosion high. pH is more, then become basic, then rate of corrosion decreases. Suppose it become pH value less than 3, this is in a high acidic condition, the severe corrosion takes place even in absence of oxygen. Even in absence of oxygen. Now what you understand that in the theory part, the acidic condition, H plus ions are there. H plus ions present in the acidic condition, they undergo reduction by gaining of electron, it liberate hydrogen gas. The continuous evolution of hydrogen gas at cathodic zone, they undergo faster reaction. If pH is less, hydrogen gas is liberated, even not required oxygen at all, they undergo corrosion very faster. There is a severe corrosion takes place in more acidic condition. Now that is the effect of pH value is less, corrosion is high. pH is more, the rate of corrosion is less. Then I come to the temperature. Now last one is the temperature. Now I think all of you know that in general, temperature is high, corrosion rate also high. Rate of corrosion also increases with increase of temperature. What is the reason? In general, temperature increases. When temperature increases, what happens? That solubility, conductivity or movement of ions or viscosity. What will happen? Now, when temperature increases, in general solubility increases. For example, you take that cold water, you put a salt, common salt, or okay, then you can sodium chloride. Just you can add and dissolve it. It's soluble some grams of crystals. Still you add that salt, it becomes saturated. The some salts are there. Then heat up. That is when temperature is high, that salt dissolves. That indicates her temperature increases, rate of corrosion also increases. Temperature decreases, rate of corrosion also decreases. When temperature increases, solubility increases. When solubility increases, automatically rate of corrosion increases. Conductivity also increases. When conductivity increases, rate of corrosion increases. The movement of ions, mobility of ions at higher temperature is more compared to less temperature. High temperature, at higher temperature, conductivity is more, mobility of ions is there, and then solubility is more, and viscosity is less. That is inversely proportional to temperature, viscosity. These are all the effects. Therefore, when temperature increases, corrosion also increases. When temperature decreases, the corrosion decreases. Now, these are the variable factors effect on rate of corrosion. Now, the remaining portion in this corrosion chapter are going to take up in the next class, that is an prevention of corrosions. Now, prevention of corrosions. Okay. Now, that is about factors affecting the rate of corrosion. Okay.